So guys, let us discuss other three important organic compound purification technique such as distillation, and then we will discuss differential extraction, and finally we will discuss the chromatography. So the first we will go for distillation, where a impure liquid compound we can purify by this distillation method, where we initially put in this impure compound in the distillation flask. We put the heating source here so that this liquid compound reach to its boiling point, so its vapor will generate, and finally this vapor will condense by its surrounding cool temperature liquid, and this vapor after condensation it's we will collect in the another pot. So by this way we can get the pure liquid. Rest of the impurity or contaminant it will stay in the flask. So here the main basic part is the evaporation and then followed by condensation. This process generally valid when the this impure mainly hot of the pure liquid have low burning less than 150 degrees centigrade, and also if main liquid component have also contaminate other liquid, if we want to separate by distillation, at least they should have that difference of boiling point 70 degree centigrade. There are number of distillation process there, but here one is the fractional distillation, another is the vacuum distillation. The fractional distillation, where that then we can apply when the difference of boiling point between the two liquids less than 70 degree. Its distillation process happens under the atmospheric pressure. So like this normal distillations also happening at atmospheric pressure. Another distillation process is which is called vacuum distillation, that is carried out in the reduced pressure, because when temperature in some cases when temperature is high, that cases some liquid or some compound have degradation ability. So in that cases we should reduce the pressure. So accordingly PV equal to nRT. That case if pressure reduced, so to make the equation without changing any volume, to make it constant, temperature get reduced, so that with low temperature we can efficiently do the distillation. So next we will see the differential extraction. So how it can separate our organic compound if there is a number of mixture of compound like inorganic or organic, multiple organic compound. So from that mixture we can put it in the separatory funnel. This is called separatory funnel. So we put the mixture and then we put the organic solvent and other is the water. So the basic fundamental here, the miscibility of our compound. If our organic compound is will miscible in organic solvent and other inorganic metal, some other contaminant, it will mixed with our water. So basically the partition coefficient works here. So we will, after putting solvent and this raw mixture of compound, we will shake this separating mixture, separatory funnel will shake, and after that we will keep for standing for few minutes, and then we will see the two different layers. So in general cases, the organic solvent layer will be the upside, and the water part will be the downside, unless this is we use that chlorinated solvent, then chloroform or other dichloromethane. That cases water will be the up, and that chlorinated solvent with our product will be the downside. So in most of the cases, that organic solvent like ethyl acetate, it will be the upside and water will be the downside. So we will just use this knob rotating, we collect these two layer separately. So by this way we can by using the differential extraction method, we can separate our compound. So main basic criteria here, the difference in miscibility or solubility of our compound in two different solvent, and we need to check this separating funnel so that maximum miscibility can happen each compound in their respective solvent. Now very important another that separation process is chromatography. So what is that? The Greek chromas mean color and the graphene means to write. Initially when it was started, people use that colorful pigment for its separation. So generally it shows some bands of color, and that was the visual separation. Generally there are number of chromatographic methods. Mainly we will discuss the two important types of chromatography. One is thin layer chromatography, that is called TLC, and it's very important in organic synthesis, that is useful for qualitative analysis of organic compound mixture. And another is the column chromatography, which generally used for quantitative estimation or quantitative analysis of our organic compound mixture. Let's first come to the TLC or thin layer chromatography. So this is the we can say TLC, where this is a one plate, that is glass or aluminum plate, and the behind, and above on that some absorbent like silica gel, alumina, cellulose, it is put it here. So this is the how this TLC looks like, I'm saying. And then let's see, this is the TLC. We just give the mark here, the base mark, and this is the upper mark. We have a solution, mixture of compound solution, and we put drop here and just pot it here, and then we put the TLC in a one jar, where the another what is the liquid phase called medium, or that is solvent is there. So this is TLC. Actually this TLC plate is the stationary phase, and when this liquid or medium, that is the mobile phase, that will by capillary action, when that will go upwards. So we don't know how many spot is there, but because of they are different in distribution, so that spot compound gets separated here. So we can just by qualitatively we can see that how many spot is there, then we can see that number of compounds in the mixture. So just to more discussion here, if we put the spot here, so because of this their ability to bind in a different type ability to bind in the that absorbent. The absorbent are generally silica, alumina. So then compound, suppose compound A moves here and compound B moves up more, that means this is little non-polar compound which is less binding affinity towards absorbent, and this is the more binding affinity, so it is a more polar compound. Now this is the base point, that is called starting point. So from here solvent move to this one, so this is the solvent reach point, and compound A reach here and compound B reach here. So now one interesting thing we have to understand, that the term called retention factor. What is that? If the compound travel that distance divided by solvent travel the distance, this one. So if for compound 1, let's see 0.8 centimeter it move, so for compound A RF is 0.8 and solvent reach, that is if 0.2, so then this will be 0.8 by 2.0, so this will be 0.4. And for B, if it is 1.6 suppose and solvent is 2 centimeter, then it will be 0.8. So this solvent or medium, whatever here uses a mobile phase, that will be either pure solvent or mixture of solvent. In general common cases, ethyl acetate or N-hexane mixture are used. Other solvent also used in other cases. Now we will come to the column chromatography. So to do this column chromatography, we need a column, that is in general cases the glass column. Here is some hollow space, here on novice there. So there we need a mixture of compound which already absorbed in the silica gel or aluminum, mix with that, so make it free. So we put the this mixture here. First we will put some stationary phase normal silica gel. After that we will put the sample mixture here, and then we will put over that the mobile phase. When like similar, when mobile phase will come down, so it will also make the our mixture of compound soluble, and it will due to the sometimes due to the gravity will come if we don't pressure upside. So then according to the same, this non-polar compound which is so the upward, it will come in the column first, and then because it have less binding affinity towards our stationary phase, and the compound A which is polar, it has more binding affinity towards our stationary phase. So slowly one by one it will come, and we can collect separately, so that now we will see some fraction. Let's see, it is a first fraction of, here we are using the conical flux we collected. So this compound A come first, and after few conicals, suppose, or in the second conical, this compound compound B come first, and after that compound A comes. So in that way we purified our mixture of compound. So also after evaporation of this mobile phase, we can quantify how much compound we are there in the mixture. So thank you guys, we will see on our next video.